Hello, dear students. Welcome to online course on linear integrated circuits. In this online course, we will cover some of the important topic of linear integrated circuits such as operational amplifiers, A to D converter and D to A converters, some special function ICs such as timer 555, VCO 565, voltage regulators, and some more important ICs we will cover in this course of linear integrated circuits. In the very first lecture, we will cover the basics of operational amplifiers, and later on we will cover some more other topics of this linear integrated circuits. In today's lecture, we will try to cover some of the topics, that is definition of operational amplifier, circuit symbol of operational amplifier, behavior of operational amplifiers, and last, ideal versus practical operational amplifier. The next two topics we will cover in lecture 3, so that now operational amplifier. Operational amplifiers, or in short op-amps, are one of the basic building blocks of analog electronic circuits. Today, in every field, these operational amplifiers are used in almost all the analog electronic circuits. Some of the fields where operational amplifiers are used are communication system, medical field, and many more. Operational amplifiers amplifies only the difference between two input signals and generate a single output. We can say an operational amplifier amplifies the algebraic difference between the two input signals and generate a amplified single output. It is designed to be used with external feedback component between its input and output terminals. Means we use some external components which are used as feedback component, and these external components, they are connected between its output and input terminals. These feedback components determine the resulting functions or operation of an amplifier. Means, depending upon these feedback component, we will decide whether the op-amp is inverting amplifier, non-inverting amplifier, logarithmic amplifier, and so on. Or we can say whether the op-amp is used as a open loop configuration or used as a closed loop configuration. By the virtue of different feedback configuration, amplifier can perform different operations. That's why it is called operational amplifier. In early days of op-amp, they were mainly used for performing some of the basic mathematical operations such as integration, differentiation, addition, and subtraction. And that is the reason why it is called operational amplifier. The operational amplifier are extensively used in electronic systems such as audio and radio communication, medical electronics, instrumentation, and performing some of the mathematical operations which we have already covered. That is addition, subtraction, multiplication, and many more. Next topic is circuit symbol of an operational amplifier. The basic circuit or symbol or schematic of an operational amplifier is shown in figure. It is basically a three-terminal device if we don't consider the power terminals. These three terminals, out of these three terminals, two are input terminals and one is output terminals. The first input terminal is known as inverting input terminals and other is known as non-inverting terminals. Two input terminals are known as inverting, which with a negative sign, and non-inverting with a positive sign. At non-inverting terminals, if we apply a input, the output is non-inverting, but at inverting terminal, if we apply a input, the output is inverting, that is 180-degree out of phase. In the next figure, it shows the operational amplifier with positive and negative voltage supply terminals, VDD and VSS. VDD stands for positive voltage supply and VSS stands for negative voltage supply. The very next topic is behavior of operational amplifier. Output voltage can be in range from minus positive to plus positive supply voltage. That is, normally op-amp have lower output voltage range, means the output voltage is always lies between these two supply voltages, but normally it is less than that of supply voltages, negative and positive. The negative input terminals produce an output signal that is 180-degree out of phase with input signal. That is, if we apply a voltage signal at non at inverting terminal, then at output the signal obtained is 180-degree out of phase with the input signal. And similarly, in positive input terminal, it produces an output which is in phase with input signal, means there will be no phase change at the output. We will study these properties later on. No current flows into either terminals of the op-amp, means operational amplifier has infinity input impedance, or we can say it has infinity input resistance. That's why it will not draw any type of current from the two terminals. Op-amp with negative feedback works as an amplifier, whereas op-amp with positive feedback or no feedback will act as a comparators. Now the next topic is how to identify the ideal and practical op-amp, or the major difference between the ideal and practical op-amp. We will consider some of the characteristics of this ideal and practical op-amp and try to find out the values of these various characteristics. The first characteristic of an op-amp is input impedance. In ideal case, it should be infinity, but practically it is not infinity, it is very high and is of order of greater than 100K. In case of mu A741, the value is 1 mega ohm. The second characteristic is output characteristic is output impedance, which is 0 for ideal op-amp, but for practical op-amp it has certain value and it always less than 100 ohm. and in case of mu 741 it is 70 ohms. The next characteristic is open loop gain. For ideal op-amp it is always infinity, but for practical op-amp it is very high and is of order of greater than 100 100k. Next characteristic is open loop bandwidth. It is always infinity for ideal op-amp, but for practical op-amp it is 1 megahertz. The next characteristic is common mode rejection ratio. It should be infinity, but for practical op-amp it is always very high and greater than 60 dB. Input bias current, it should be zero, but it is not zero for in case of practical op-amp. It is always less than 50 nanoampere. Next is offset voltage. It is zero for ideal, but practically it is very low, that is less than 10 millivolt, 10 millivolt. Next characteristic is slew rate. It should be infinity for ideal, and for practical op-amp it is few volt per microsecond. And next is thermal drift. It should be zero for ideal op-amp, and for practical op-amp it is very low. The equivalent circuit of an operational amplifier. Figure 1 shows an equivalent circuit of an open operational amplifier. Here this RE, R0 and A, they are the input resistance, output resistance and open loop gain. AVID is Thevenin equivalent voltage source and R0 is Thevenin equivalent resistance, taking into or back R0 is Thevenin equivalent resistance looking back into output terminal of an operational amplifier. The output voltage is given by AVID, where VID is the difference input voltage, that is given by V1 minus V2, where V1 is non-inverting terminal and V2 is inverting terminal. We are considering V1 positive and V2 negative voltage. In the next lecture, we will try to cover the voltage transfer curve. Thank you a lot.